Hey guys, welcome back. In this video, I'm going to create this 3D relief image using a colored image. So basically you can see right now I have this geometry nodes graph, and over here in the second panel I have this relief image. I've also added a point light, and let me move it around, and this is our relief image. So basically to create this relief image we need a colored image and a depth image which is extracted from that same color image. Now this video has two parts. In the first part I'll show you how to use geometry nodes to use that depth image and create this relief, and in the second part I'm going to use Python, yes, the Python coding language, to generate or to extract the depth image from the colored image. So it's not going to be too difficult, and don't worry if you have no experience with Python or coding. You just have to follow my instructions and you'll be able to get the right output. Let me also show you the colored image and the depth image. So this is the colored image. We have this face of a dragon in 3D style, and this is the depth image generated from that colored image. It's basically a grayscale image. The gray regions of this image represent the regions that are further from the observer, and the lighter shades represent the areas or regions of the image that are nearer to the camera or to the observer. Now let's get back to the Blender and get started. Let's add a plane and resize it. I'll then subdivide the plane 10 times. Select all the points, right click, again subdivide. Let's make it 10 times again. So we have divided our plane 20 times. If you check the statistics, in this plane there are over 14,000 faces or polygons. Let's add a geometry nodes graph. Add a set position node between input and output. Then add image texture node. Click on open and select the depth map image. Now add a named attribute node, and in the name field select UV map. Then from the color output of image texture we will connect the separate color node and change the mode to HSV. In HSV mode we get the value output, and we will connect that to combine XYZ, connect it to Y, and then connect vector output to offset. Now let's flip the plane, and there you go. So this is our 3D relief. Here I'll do one more thing. I'll add a smooth corrective modifier. So as you can see, the relief has already become more smooth. And then we have these parameters, factor and repeat, that we can use to tweak the smoothness of this mesh. Here we can also add subdivide mesh, and it will make the relief more smooth. However, be careful, if you increase this level, let's say increase it to 2 or 3, the number of polygons in this mesh will also increase, and that can consume more computation. Let's connect a multiply node between separate color and combine XYZ, and we can use this value in the multiply node to change the height or depth of this relief. Finally, just before the output, I'll add set material node. In the side panel, I'll create a new material or texture. Let's give it a name. Select the same texture in the node, and in the shading editor, you can define the texture for your relief. I'm going to use this simple texture, this dark gray color. Let's also increase the metallic value. I'll add a point light. Just in front of the relief image. This is the render view, and I'll increase the power of this light. Okay, so our 3D relief is ready, and you can play around with different types of lightings. You can change the color of the lights as well. And once everything is done, just select the relief, right click, and click on convert to, then mesh. Both of these modifiers, geometry nodes and smooth modifier, will get applied. Now let's move on to the next section where I'll show you how to generate that depth map with the help of some Python code. So this is a GitHub page. GitHub is a website that allows you to share your code in any programming language. I provided the link of this page in the description section below. Let's use the first link over here, and it will open up an interface that is called Google Colab. So Colab or Google Colab is a Google product that lets the users run Python code for free. So it's basically a cloud server where you can run your Python code. All you need to have is one Gmail account. It's a good practice to create a copy of this Colab notebook on your Google Drive. You just have to click on File, then Save. So I've created a copy for me, and it has already been saved in my Google Drive. Next, I click on Connect in the top right corner. So it will take a few seconds to connect to the server. And once it is connected, I'll be able to run all these code. You can see in this Colab, our code is divided into blocks or cells. And to run a block, click on this play button. Some of the blocks will execute faster than the others. For example, in this second block, many Python libraries are getting installed, which are required to perform this task of converting colored image to depth map. Okay, it is executed now. Now we will move on to the next cell. Click on play button. It will start executing the code. Alright, this is also executed. Now over here, we will click on this play button again. And now we can upload our image file, the colored image file, by clicking on choose files button. So our image file is getting uploaded, and this code will then start generating the depth image automatically. It can take a few seconds or a few minutes, and you will be able to find the output image or the depth image in the side panel on left hand side. So there is a file at the bottom, Zoe depth map 16-bit low. This is what we are interested in. It's a grayscale depth map image, and we will simply download it. As you can see, this is the depth image I am talking about. It's grayscale, and the shades of gray represent the depth of the image. Once you have downloaded the image, you must shut down this Collab notebook. And for that, click on Runtime, Manage Sessions, then click on this Close button, Terminate. So now you have disconnected from the Google Colab server, and it will save your GPU credits. So Colab provides some free credits to use their GPU, and I think it has a cap, a monthly cap or weekly cap. So it's always good to shut it down once you are done. Thanks for watching.